everybody, my name is Allie and we are going to be giving a tour of USC's Rocket Propulsion Lab. I'm going to be behind the camera and our tour guide over here.
Hi everyone, my name is Alex. I'm a senior studying astronautical engineering and I'm super excited to introduce you to the Rocket Lab where I work and where I spend a bunch of time.
Woohoo.
So let's get going. So right now we're currently walking through RRB, RAP, which is a building on campus that's home to a bunch of different labs and research groups. Allie, show them the whole. So right here, this is chaff.
Wow.
So this is all just on the walk to Rocket Lab. We're not even in the lab yet. This is chaff. Actually, Allie, peek inside here. This is a vacuum chamber that essentially the idea is it gets so cold on the walls that the air molecules stick to the side of the walls such that it creates a vacuum within the chamber itself. So this is
cool.
Dr. Gilpin, who's actually, I work for him as a teacher's assistant for Mech Optronics, and he was my professor last semester for senior design. He runs this lab. He has a bunch of undergraduates who work underneath him. So here's some stuff. This is all just an RRB. We're touring Rocket Lab, but a quick segue as we get to Rocket Lab through all this really cool machinery. And it's really nice that undergrads, I mean, I've walked through this building millions of times every single day. This is like a research home for aerospace and astronautics.
Can you tell me what this is? This looks scary.
Oh, this is the same thing. This is still chaff. I'm not exactly sure what that particular duck does, but.
Oh wow. Yeah, I feel like it could suck a person up there.
Yeah. Also, feel free if you're on live, shoot us questions. Allie will tell the question to me, and I'll do my best to answer it.
Sounds good.
Yeah. So here we are. Oh, this is really fun. So here we have an old nose cone. Not sure what rocket this was on, but this is basically look at the inside here.
Oh wow.
That's fiberglass. This is a cork nose cone.
So this outside is made of fiberglass?
Sorry, no. The inside here, this yellowish stuff, that's fiberglass.
Okay, got it.
And then this outside brown is cork, and we use that for thermal protection. So the rocket is going up around, DCX, which was our last attempt to reach space. Went up around, was supposed to get to Mach 7, and this stuff is going to protect it from the intense heat it's going to feel as it's accelerating through the upper atmosphere.
Cool.
And I'll explain kind of more about the lab and what DCX is and what we do as we get there. So we're moving. Let's go.
Yes. Wow. This is another.
Yeah, another
crazy
vacuum chamber.
Cool.
And we're not even in a rocket lab yet.
Someone down there. Oh, there's me. Hello.
Oh, safety first. We're gonna put on safety glasses.
Oh, yay! Viterbi fashion.
Here, viewers, wear your glasses. Just kidding. I'll put this on Allie. All right. And I'm gonna grab some glasses as well. So, welcome to. Great. This is Rocket Lab. Welcome. Hi, Christian. Welcome to Rocket Lab. So, essentially, to kind of give you some background, Rocket Lab is a completely undergraduate student design team with the goal of putting a rocket into space, past the Von Karman line, 100 kilometers. And if you look up, these are rockets, and a lot of them intense. No, he's fine. Well, I'll talk really loud so you can hear me. If you guys can't hear me, comment so we can tell Christian to turn off the lathe, but we should be good for now.
Someone just commented Christian is lame.
Oh, someone commented, Christian, someone just said you're lame on the Periscope. Sorry about that, buddy.
Luckily he can't hear.
so this is the lab, and basically we're currently working on, we're getting prepared for 2 static fires this weekend to flight qualify a nozzle, but basically, and to test the motor for our latest flight vehicle, which will be Fathom. Fathom will test a lot of the aerodynamic properties of our space shot rocket, but for now we'll kind of take you through the lab, introduce you to a few people. We'll get to that stuff as we go. Please ask questions.
What is this?
Oh, this?
This looks scary. This looks like someone died and was like trying to escape.
That is exactly what it is. No, this is last night so let's get a shot of this. This is a carbon fiber case. So what you might have heard about us is one of Rocket Lab's core competencies is the ability to develop carbon fiber motor cases. So essentially, this is the main body of our rocket, and we were going to test fire our engine with this motor case, and we had to do what's called an R45 repair. So this stuff, this sticky stuff that I just touched.
Yeah, good call on
that. This is R45, which basically plugs the holes in the carbon fiber itself and allows us to fire it again with without losing much pressure
Got
from the
it.
combustion gases.
Let's see if
hey,
you can
let's
tell.
get Ryan. Hold on.
Oh, yep.
Ryan, come over here and say hi. Ryan's a senior in Rocket Lab.
Real live engineers.
Ryan also started his own skateboard company. Using also carbon fiber. You want to tell the world about your skateboard company?
Yeah, so 121C Boards is a company that takes carbon fiber from the aerospace industry and then waste carbon fiber from the aerospace industry and then turns it into useful products. And our first is an unbreakable skateboard.
I follow them on Instagram.
Cool.
Yeah, thanks, Ryan. So Ryan's our CFO and
chief composites engineer as well.
And chief composites engineer. So Ryan knows his stuff about rockets and composites, and he's gonna be rich when his business takes off. Thanks, Ryan. So basically, and Allie, if you wanna jump in here at any time, like please feel free.
Is this live?
This is live. This is a live stream.
Live.
Yeah.
Oh,
With the world.
Hi, world. Hey.
All right. So here we have Here's
Oh, I thought this said floating machinery. Rotating machinery.
Rotating machinery. Yeah, so this is how we develop the motor cases that you kind of see here. We essentially have carbon fiber on that spool, and we wrap the carbon fiber around this handle here. And this is basically the filament winder.
Cool.
And that's how we build the motor cases that we use for our space shots and for our static fires. So kind of looking up. Allie, let's see that rocket right there.
Yep.
See this one with two. That was our last attempt to reach space. That's DCX.
This has a hole in the middle. Is
Yes.
that the one we're looking at?
Yeah, it has two holes, one in the middle, one not in the middle.
Oh, yep.
And DCX actually was a 6-inch rocket, 6 inch in diameter, excuse me. And the idea, what we determined was, as you can see, there's holes in it. We launched that one out of Black Rock Desert, Nevada, in October of 2014, and it failed due to a thermal problem. Essentially, the hot combustion gases melted the carbon fiber. Traditionally, what was called phenolic, a layer of, it's basically a layer of material to protect the carbon fiber from the heat. The phenolic failed, it burned up. So now, kind of the push of lab in the last, probably over the spring over last year has been developed these rubber cases. So you can see the rubber duck.
Hey.
So this is the rubber ducky series. Essentially, we would static fire these cases with a rubber liner as opposed to a phenolic liner, because rubber is a much better material to protect the carbon fiber.
Why are there
motor
holes?
case. That's so we basically you have to pin in retention rings and bulkheads into the carbon fiber, and that's we basically would when you stick the bulkhead in, you pin it, and we have to have the bulkhead to basically keep the motor in place, and keep the motor in place, be able to put the nozzle in, and be able to, when you have a flight vehicle, put in the avionics unit and the recovery bay, so like the parachute and stuff like that.
Cool. Why does it have a parachute? Because you want to collect it at the end, or
Yeah. So the idea
is the goal it's reusable?
Oh,
You're not
that's
trying to re-land it. It's not like SpaceX.
No, so it's not like SpaceX in the sense that we're not 100% trying to land it. A quick segue, a lot of the carbon fiber we get is donated from SpaceX, and that's one thing that really we share with SpaceX is our use of carbon fiber. But a segue, sorry, that was just a quick thing. But yeah, we're not trying to land it again, but we do want to recover it so that we can hang it. So the idea is...
We can hang it.
Hang it.
For decoration.
Yeah, for decoration. So look at this one over here, Al. This one, this is DCX. The idea, DCX actually flew, or sorry, this is Deja Vu, I apologize. Deja Vu, as the name kind of suggests, flew twice.
Okay.
So it was reusable.
Oh, wow.
Yep. So basically, it went up to...
It was a very pointy top.
Yeah, it went up to 28,000 feet. The parachute deployed. It came back down, recovered it. That was in November 21st, 2015. My 21st birthday, actually.
Hey.
And then we just launched it again in February. And same thing. Went up, parachute deployed, came back down. And the idea why we launched it twice was an avionics recovery test bed. So the same idea with any science class. You have to have a control scenario such as you can take the independent variables and measure them twice. To see just to make sure that the avionics recovery, our independent variables, would work twice under the same exact conditions. They both did, and the Deja Vu came down safely.
How much does this weigh? Can I touch it? Am I allowed?
Touch it? Yeah, I don't know.
Sure,
How much does Deja Vu weigh? Do you know? Dry or wet? Both. What's the dry and wet mass?
I don't know. I It's very heavy, I assume, though.
Oh, that's not too. I mean,
Like, you can pick it up?
Yeah.
No.
I can pick it up. Look at that.
Okay, so it weighs as much as Coco can bench press.
Yeah, I mean, I would use my body if I wasn't wearing a nice shirt, but
Sure.
Yeah, sure. Thanks, Ali. Oh, so I want the world meet Ali Garrus. Ali's our chief propulsion officer and a total rock star.
What do you do as part of the club?
So I'm the chief propulsion engineer. I'm also the chief communications officer. So in terms of engineering, I am responsible for making the stuff that lights on fire.
Dope.
And as the communications engineer, I'm in charge of like outreaching to potential students, making sure that like companies know who we are, stuff like that.
Cool. That sounds like a lot of fun.
It is.
The fire part.
Mostly the fire part. That's my favorite part.
Yeah, I can imagine. That's awesome.
Great. Thanks, Ali.
Cool.
Let's go over to the avionics bench and check that out.
Is that over here?
Yeah.
Awesome.
Yeah, sorry it's so messy. We're getting ready for the static fire.
It's suspicious, though, when a lab is clean, from what I've found.
That means they're hiding something.
Exactly.
So, this is the avionics bench. You know, it makes sense, but in order to have a functioning rocket, you need good electronics. So, Carter, who's an astronautical engineering major, and Adam, who's an electrical engineering major, they developed Hamster, which is essentially our own custom-built electronics to put on the rocket that allows us to measure the altitude and speed of the rocket as it ascends and then descends, and also gives us GPS measurements of where the rocket is. And this is all custom built. Adam and Carter designed this, ordered the parts, built it themselves, and this goes inside a rocket, and we can proudly say we flew a hamster.
Hey.
Twice on a rocket, which is pretty cool. This one went up in Deja Vu.
And so this is where you get the majority of the data analytics after the launch?
Exactly.
Okay.
So that's where we get all the data, but it's also sent to our computers in the bunker during launch stuff. So we get live updates of where it is, how fast it's going, and how high up it is.
That's awesome. Very
Yeah.
cool. And have they had to build multiple of these if something ever explodes, or like is this always recoverable?
So it's not
Does
always
stuff
recoverable.
explode?
So stuff explodes. So you remember? So let's look at
The
there's
holes.
DCX right there.
Yeah.
DCX obviously that one exploded, and we didn't. I think we didn't recover. Even GoPros die with that sort of impact. 'Cause remember, you're about 10,000 feet above the desert lake bed, and you just have a huge explosion. Everything's tumbling back down to earth. The impact speeds, we've broken GoPros, we've broken all the sensitive electronics.
Yeah.
So in the case of an explosion, 9 times out of 10 you're losing all of a sudden, you start over from scratch.
Yeah.
But we've been really lucky. We've had back-to-back successful launches.
Woohoo, knock on wood.
Yeah, knock on wood, Fathom will be successful as well. Fathom's our next launch, which will be towards the end of April.
Cool, that's coming up.
Yeah, coming up. That's why we're static firing this weekend. Hi, Sky.
Hey, what's up?
Nothing much. Cool. Let's go this way. We'll check out the lathe and mill. Also, forgot to mention, Allie's working at SpaceX over the summer, which is awesome.
Very cool.
Propulsion.
In propulsion. Sky, you're also working at SpaceX over the summer, right?
Yeah.
Christian is working at Blue Origin, which is Jeff Bezos' rocket company. Aaron just has a great beard.
So some very successful people in this shop.
Yeah, so we're pretty successful.
And where are you working, Coco?
I'm working at Boeing, corporate aerospace.
Hey.
I'm really excited. I'm going to Huntsville, Alabama to work on Space Launch System. So another cool perk of the lab is that we have a mill and a lathe that we can use at all hours of the night whenever we want to use it. It's completely maintained and run by us. It allows us here. We'll get a close-up view of Christian working on the lathe here.
Can we get close to this? This seems scary and dangerous.
Go on that side. Go around Christian. Go on the back side. That's
Should
okay.
I go
Is that
around
okay
on
with
this
you?
side?
No. Walk towards Christian.
Yeah, don't stand in front of the truck.
Yeah,
Yeah.
for
So
sure.
we're gonna stand right here and we're gonna watch Christian work. And
So I'm
going.
working on a nozzle right now. It's just like the back side of a nozzle that's unfinished that we're gonna actually fire out in the desert on Saturday. So a couple of days away, and we're testing out a new nozzle design. So getting This guy machined tonight, and then we're going to build another one with a slightly different internal design using different materials today and tomorrow.
Dope.
Let's do it. So a lot of our guys are lathe and mill trained. This is a really cool skill to have when you go out in the industry, knowing how to work with hardware, how to build hardware, how to take 3D CAD drawings and turn it into physical parts. That's one way in which our lab is very unique. A lot of other labs don't have that with their own lathe, their own mill. And yeah, that allows us to work fast and get a lot of things done. And also be very confident in what we do. That's okay. Are you trimming the? So we're just trimming the outside diameter of the nozzle now. What material is this? Stainless? No. So it's aluminum. So it's pretty soft. So it should be easy for Christian machining. Christian had to, for our senior design project, Christian had to machine a combustion chamber. Got to think of a stainless steel about that wide maybe. He also had to pour out the inner diameter, and that took him forever. Days, really. How long does this take, Christian, to finish? Yeah.
Like 4 hours.
So it'll take Christian 4 hours to finish this up. Do you want to Allie walks behind? Goes this way? Okay, thanks, Christian. Sorry. All right, thanks, Christian. Woo! All right, so also what's really neat about the lab is we really pride ourselves on also being a great resource for underclassmen. So we have kind of this study space here. We all hang out here, study together. It's a very social group.
Cool.
And we make sure to help freshmen out of their homework, help sophomores out of their homework, and just have a good time while we work.
Awesome. I think we're good. If we don't have any more questions, we've just given a tour of USC's Rocket Propulsion Lab. And your next, he said he was launching something on Saturday.
So, excuse me.
Testing.
Sorry, live sneeze.
Just as someone joined too.
Really, that's great.
Mid-sneeze.
Sorry. So we're doing a static fire.
That's a dad. It looked like you were
we're doing a static fire this weekend out of Mojave to test this new nozzle that Christian's working on and to test the motor that we're building, the actual physical propellant itself. Then we're launching Fathom, an aerodynamic test vehicle, at the end of the month to test this new aerodynamic profile. We were seeing in past flight vehicles that are on Mach 1, the rocket would kind of take a right turn for the worse and kind of lawn dart into the ground. So we realized, we actually read a bunch of Air Force papers, determined that we had to change the aerodynamic profile of our rocket, and that's what we're doing with Fathom. So we're changing the profile and see what happens.
Cool. So I think we are just gonna wrap up now. It's
Bye,
always sunny in
everyone.
LA.
Thanks for joining us. Really appreciate it.
Thank you. And we have another Periscope Live tour of the robotics open house tomorrow at 11:30, I think. So check back for our Twitter then. Thank you so much, everybody.
Bye.